While playing billiard, players often twist the end of their cue on cube-shaped substance, which easily disintegrates into a fine powder. Limestone is essentially calcium carbonate, which is commonly called chalk. Have you ever wondered how this chalk is made? Let's find out. Chalk was used on the ends of cues even before the leather tips were used, in order to prevent or reduce miscuing. Originally, the chalk used was white, but this made such a mess of playing surface that the green and blue chalks were introduced, which were not so noticeable on the green playing surface of the billiard cloth. Blue has been the traditional color for billiard chalk for about 100 years. Now other colors of chalk are available to the range of colored pool tablecloth available. Chalk is applied to the tip of the cue ideally before every shot to increase the tip's friction coefficient so that when it impacts the cue ball on non-center hit, no miscue occurs. Chalk is an important element to make good shots in pool or snooker. Q-tip chalk is not actually the substance typically referred as chalk, which is generally calcium carbonate, but any of several compounds with a silicate base. During the time of the Industrial Revolution, newer compounds formed that provided better grip for the bow. This is when the English began to experiment with the side spin or applying curl to the bow. This was shortly introduced to the American players and is how the term putting English on the bow came to be. The earliest reference found concerning the use of the chalk in order to give the cue a better bite or grip seems to indicate that during 1820s, Edward Bartley of the Bath first used chalk in order to apply screw or side to billiard balls. Having discovered the advantages of using chalk for this purpose, he astonished the spectators by the shots he was then able to play. John Carr, who acted as a marker, came to know the secret and apparently made a small wealth by selling twisting chalk to the other players with the promise that they would be able to perform similar shots. As many players will admit, chalk on the tip of a cue certainly makes a tremendous difference to the player's ability in controlling the cue ball. His product was simply calcium carbonate, which is naturally white in color, but anyone can sell white chalk. Carr's brilliance was twofold, calling it magic and coloring it blue. Chalk remains blue today because of Carr's shotgun. At least that's a legend and the story to tell, even it's true or not. Michael Sheamus, in the New Illustrated Encyclopedia of the Billiards, calls the story of Carr a myth, since it doesn't appear in any work associated with his life. Sheamus indicates that blue chalk emerged in 1828 and the green chalk in 1843, but gives no details as to where or why. It was quite clear that chalking the leather tip was well known by 1841. A handbook to the game of billiards called Chalking the Q-tip essential, but gives no details about the type or color of the chalk. Phelan's work of 1850 advises that chalk should be entirely free from dirt or grease, but mentions nothing of its color. During these years, the dominant chalk color was white, owing to the simple manufacturing process. Large blocks of chalk were cut from solid natural limestone deposits. The large blocks were then recut into smaller cubes and sold in their natural color white. But white chalk was proving to be problematic. The cubes dried up, lost their form and easily disintegrated. And white chalk itself was, well, too white. It spoiled the appearance of the green cloth after a few games and was difficult to clean. In year 1884, Anthony Pepple, a billiard player from Brooklyn, described the problem in his application for a patent for a substitute for billiard cue chalk. The messiness of white chalk explains the need to color chalk. Pepple sought the patent protection for his invention, a compound made by mixing coloring agent with a chalk and perhaps some silica or magnesium. The coloring agent would be the color of or nearly so of the billiard cloth, so that the cloth will not be spoiled in its appearance by small particles that will eventually fall or rub off the balls upon such cloth. Hence, the cloth will not require to be brushed off so often or so severely in cleaning the same, and it will not be worn out so rapidly. For convenience, people compressed the mixture into blocks, which were then covered by a paper on all sides but one, so that the fingers will not be soiled in use of this Q-tip material. In his application, Pepper preferred to use chrome green as the coloring agent, but also listed magnesium green and ultramarine green as other possible colors. Pepper was awarded his patent on April 14, 1885. The Brunswick Bog Colander Co. started marketing green chalk in 1885 based on Pepper's patent. There was resistance to the colored chalk as players were used to the white billiard chalk imported from Europe. At the same time, entrepreneurs and inventors were experimenting with the various chalk substitutes. In the 1890s, a chalk substitute became popular in Paris. This chalk substitute, which had remarkable properties for clinging to the Q-tip, became known as the French chalk, but was also called the Italian chalk because it was mined in Sicily from porous volcanic rock deposits found near Mount Etna. The volcanic rock was crushed, mixed with a blue coloring agent, and formed into blocks. Barclay players Jacob Schaefer Sr. and Frank Ives brought pieces back to America and raved about its capabilities. The Chicago Tribune concluded that it had improved their play by 15%. In the early 1890s, William A. Spinks, an American Barclay player of note, brought a piece of blue Italian chalk to a chemist, William Hoskins, for analysis. The Italian chalk contained large quantities of silica and corundum. After experimenting with the various formulas designed to replicate the natural composition of the Italian chalk, they arrived at the chalk substitute consisting of 80 to 90% silica, a binding agent, glue, and abrasive compound, corundum, and a coloring agent. Their chalk substitute was superior to the natural chalk and to the Italian chalk. Therefore, Q-tip chalk we see today was invented by straight rail billiard pro William A. Spinks and the chemist William Hoskins in 1897. Q-chalk were made of silica and the abrasive substance corundum or aluminum oxide. In making process, silica and the abrasive substance corundum or aluminum oxide were crushed into a powder. After making the powder, it is combined with dye, which is originally and most commonly green or blue-green, like traditional billiard cloth. Hoskins and Spinks were awarded patent number 578514 on March 9, 1897. Hoskins and Spinks also noted in their application that their substitute chalk could be colored so that no mark will be left upon the cloth as it falls from the Q-tip. But we prefer to give to the substitute a color which may render its presence on the cloth of the table to be readily observed, as it may thus be more readily removed. Like Pebble, Hoskins and Spinks also indicate a preference for chrome green as the color. They came to manufacture their chalk substitute in various shapes: a triangle, a cylinder, a cube, colored either chrome green to compete with the Brunswick Bog Colander chalk, or ultramarine blue to compete with the Italian blue chalk. It sold for 25 cents per piece, more than 3 times the price for the white chalk. Spinks chalk was a huge success. In 1901, however, a federal court ruled that Hoskins Spinks patent was invalid. Competitors flooded the market with the colored silica-based chalk, and the blue proved more popular among the players and room owners. Over a century later, blue is still the most popular color. Nowadays, a huge variety is available in the market. Each manufacturer's brand has different qualities, prices, which can significantly affect play. High humidity can also reduce the effectiveness of chalk. Harder, drier compounds are generally considered superior by the most players. Thanks for watching.